All right, let's dive right in. Today, we're going deep on the architecture of smarter AI. We're going to talk about two really powerful technologies, vector databases and knowledge graphs. But more importantly, we're going to see the incredible synergy that happens when they work together. This is how we build the foundation for AI that's truly intelligent. So, let's get into it. But first, let's start with a question you've probably asked yourself. Why is it that these super advanced AIs, the ones that can write code or a beautiful poem, can sometimes feel, well, a little clueless? Why do they forget what you told them 2 seconds ago, or just not get some basic real-world connection? That right there, that's the core problem we're going to tackle. So here's our game plan. We'll kick things off by talking about something called the AI knowledge gap. Then we'll meet our two main players, vector databases and knowledge graphs. We'll put them head-to-head to see what makes them tick. And then, and this is where it gets really cool, we'll see how combining them unlocks a whole new level of AI intelligence. Okay, so Section 1, the AI knowledge gap. And this really all comes down to one big challenge, context. You see, large language models, or LLMs, are absolutely brilliant at churning out text, but they don't have a stable, long-term memory. They lack a structured way of understanding how the world actually fits together. To put it really simply, LLMs are incredibly smart, but they're also super forgetful. They kind of just live in the moment, operating within a very short window of context. Without some kind of external brain to help them store and retrieve information, they just can't build a consistent, factual picture of reality. And this is the exact problem that our next two technologies are built to solve. So let's bring in our first solution, the vector database. I like to think of these as the masters of meaning. Their whole job is to understand the fuzzy, nuanced, and contextual relationships between ideas. And the way they work is pretty fascinating. A vector database doesn't actually store words or pictures in the way you might think. Instead, it turns everything into these really complex lists of numbers called vectors. And here's the magic. Things that have a similar meaning end up having similar numbers. This makes it insanely fast to find stuff that's conceptually similar, even if they don't share a single keyword. A great way to picture this is to imagine a librarian of vibes. This librarian doesn't care about the Dewey Decimal System, no. They organize books based on their feel, their tone, their themes. So a sci-fi novel that's all about hope might be sitting right next to a historical biography about perseverance. It's all about the underlying meaning, the vibe. And at a high level, the process is pretty straightforward. First, you feed it your data, text, images, you name it. Then an AI model embeds that data, turning it all into those numerical vectors we talked about. And finally, when you ask a question, the database doesn't scan for keywords. Nope. It looks for the vectors that are mathematically closest to your query's vector. It finds things that are like what you asked for. Now for our second contender, the knowledge graph. If vector databases are the masters of meaning, then knowledge graphs are, without a doubt, the masters of fact. They're all about precision, structure, and explicit, undeniable relationships. A knowledge graph is built on a really simple but powerful idea. You have nodes, which are things, a person, a company, a city, and then you have edges, which are the lines connecting them that define the relationship. So you might have a node for Paris connected to a node for France with an edge that says, is the capital of. It's just a giant web of interconnected facts. The perfect analogy for this is a classic detective's corkboard, right? You've got the photos of suspects and locations, those are your nodes. And you've got the red string connecting them all, showing motives, timelines, and connections, those are your edges. Every single connection is deliberate and explicit. There is zero ambiguity. Okay, so we've got the librarian of vibes and the detective's corkboard. Two totally different ways of thinking about data. So let's put them in the ring for a showdown. Similarity versus structure. It really boils down to this. Vector databases live in the world of fuzzy meaning. They get that king is kind of like queen, or that joyful is the opposite of miserable. Knowledge graphs, on the other hand, deal in hard facts. They can tell you exactly who the CEO of a company is and the date they were hired. One is all about nuance, the other is all about precision. And this table here really lays it all out. Just look at the data model. Abstract vectors versus concrete nodes and edges. Their best uses are totally different too. Vector databases are amazing for semantic search, while knowledge graphs are built for specific factual questions. And the query style says it all. It's the difference between asking, find me things that feel like this, versus asking, tell me exactly how X is related to Y. Which brings us to the real heart of this whole explainer. For a long time, the debate was vector database versus knowledge graph. But the future isn't about picking a winner. It's about moving from versus to plus. It's all about synergy. So, do we really have to choose? Is it the master of meaning or the master of fact? The librarian who gets the vibes or the detective who knows the connections? The answer is a huge no. In fact, they are so much stronger together. Think of it like this. The knowledge graph provides the factual backbone, the skeleton of pure truth. Then, the vector database comes in and fleshes it all out, handling all the messy, unstructured context and nuance that surrounds those facts. When you put them together, you give an AI both a rock-solid memory and a deep understanding. And here's what that actually looks like in practice. So, an AI gets a tough question. First, it pings the knowledge graph to pull all the verifiable facts, the who, what, where, and when. Step 2, it uses a vector search to find related articles, documents, and conversations that give it all the context and nuance, the why and the how. And finally, the LLM takes those hard facts and that rich context to generate an answer that's not just accurate, but also genuinely insightful. This isn't just a minor improvement, it's a whole new paradigm. This synergy is paving the way for the future of AI reasoning, taking us beyond just matching patterns to something that starts to look a lot more like real comprehension. So, at the end of the day, what we've seen is that synergy is everything. If we want to build truly smart AI, we need systems that don't just know the what, the facts from the knowledge graph, but also understand the why, the context that comes from the vector database. Which leaves us with one last big question to think about. What happens next? What kinds of problems in science or medicine or art are we going to solve when our AI partners can truly reason about the world instead of just reciting information back to us? The possibilities are pretty extraordinary. Thanks for tuning in.